Hello guys, welcome to Ferdinand Tutorials. In this video, I'm going to be looking at 40 likely questions you are expected to be seeing in your JAMB examination. I will show you how it is to be solved, and you will learn the simplest way and better ways to answer this question in your examination. Now we have question 40. It says, what current in ampere will deposit 2.7 grams of aluminium in 2 hours? Are we there now? Now they give us aluminium 27. Please don't mind this. This is a side stuff. Now we say aluminium 27 F96500. Now they give us option A 32, option B 8, option C 4, option D 16. Now let's look at the parameters that we're given. They give us mass as what? 2.7 grams. They give us molar mass of aluminium as what? 27. They give us Faraday constant as 96500. What else did they give us? They give us time. Now remember, when we're solving questions in Faraday's electrolysis, our time is usually in seconds. So they give us 2 hours. We'll convert 2 hours to seconds. 1 hour is 60 minutes, which is 60 times 60 times 600 seconds. So for 2 hours, 2 hours will be 3,600 times 2 times 2. So our time is usually 3,600 times 2, which is 7,200 seconds. Are we there now? 7,200 seconds. So if we have here, now we say that we are looking for I. Remember, we say that according to Faraday's law, we say that mass is equal to ZIT, where Z is equal to what? Electrochemical constant in Faraday, which is given as what? Which is what we usually use to solve our question. And then we have I, current, we have T as time. So in this scenario, we're going to say that we want to find I. I'll make I the substitute of the formula. I will now be equals M over what? Over ZT. Are we there now? Over what? Over ZT. So in this scenario now, we don't know what our Z. They didn't give us Z. We say that Z will be equal to molar mass all over what? All over NF. That's how to solve for Z. So if we solve Z, we impute it here and solve for our current. Are we there now? Where molar mass is given, F is given, but they didn't give us N. So how do we find N? Since we're talking about aluminium, so we look at aluminium. What is the charge of aluminium? Al3 plus. Now plus 3 electron. Are we there now? To give us what? Aluminium. So that means the number of electron here, which is N, is what? Is 3. So when you hear about N, N is what? Number of electron. So in this scenario now, we're going to say our molar mass is 27 all over. What is our N? Our N is 3. What is our F? Faraday's constant, 96500. Are we there now? So we're going to say our Z will be equal to 27 over 3 times 96500. We have 289,500. 289,500. So 27 over answer, we have 9.326. 9.326 times 10 raised to power minus 5. Are we there now? So I will impute the value here. We say current will now be equals, anyway I see mass, what will I put here? 2.7 grams. 2.7 all over. Now anyway I see Z is the same thing as 9.326 times 10 raised to power minus 5 times, what is my time? 7,200 in seconds. Are we together now? So I will say that my current will now be equals 2.7 all over. Now 9.326 times 7,200. Are we there now? Now this is, let me show you an easier way for your JAMB. When you don't have all this kind of calculator, you just have crayfish calculator. So what you can do, the easiest thing to do is just you bring out these whole numbers. You say 9.326 times 7,200. Now remember 10 raised to power minus 5. It is, if it goes up, are we there now? It will turn to positive. So this is something as current is equal to 2.7 times 10 raised to power. This one comes up now, it will be positive 5 all over 9.326 times 7,200. I have 67147.2. Are we there now? So I will say current will be equal to, I will say 2.7 times 10 raised to power 5. Are we there now? Is the same thing as 270,000 all over 67147.2. So my answer current is 4.021 ampere. Are we there now? That's my current. So the answer is C. Are we there now? 4 ampere. which is what? 4.02, because the nearest whole number is 4. Now question 39, it says, in which of the following reaction does reduction takes place? In which of the following reaction does reduction takes place? Now, let me tell you the easiest way. Apart from saying that reduction is a, rig, reduction, we say reduction, we have what we call rig, and oxidation is oil. Reduction is, gain, oxidation is loss. Remember that here, I want you to understand something, that when we're talking about increase in oxidation number, when the oxidation number moves from 0 to 1, are we there now? That is an what? That is an increase. That is oxidation. Now, when the oxidation number moves from 0 to -1, that is what? Reduction. Say, for instance, I have something like this: sodium plus chlorine, and then I have NaCl. Are we there now? Now, the oxidation number here is 0. Here is 0. Are we there now? Here is what? +1. Here is -1. If you've not watched my video on oxidation, the video is in my JAMB playlist. Go and watch and learn about oxidation and reduction. So if I move from here to here, this is increase. So this is reduction. Are we there now? This is increase. So this is oxidation rather. This is oxidation. If I move from 0 to -1, this is what? Reduction. So if I want to answer this question now, here, how to identify whether a reaction is oxidation or reduction when we involve electron. Whenever electron is at the right hand side, that particular reaction is oxidation. Whenever electron is at the left hand side, that particular reaction is what? Reduction. Plus electron at the right hand side is what? Is oxidation. Plus electron at the left hand side is what? Reduction. Look at this is left, this is right. This is left, this is right. So where can we see plus electron at the? Because they're asking us of reduction. So plus electron at the left hand side. That's what we're talking about, what? Reduction. Are we together now? So we'll come here, this is minus electron, it's not the answer. There is no electron here, this is minus, it's not the answer. So when we come here, when we have plus electron at the left hand side, this is what? This is reduction. When we have plus electron at the right hand side, it is what? Oxidation. So the answer here is what? Is D. To question 38, an element X with a relative atomic mass 16.2 contains two isotopes. X with an atomic number 8, mass number 16, with a relative abundance of 90%, and X with an atomic number 8, mass number M. That's what we're looking for. So they say with a relative abundance of 10%, the value of M is dash. They didn't give us the value of M, they asked us to find. Isotopes are elements that have same atomic number, but different what? Mass number. So anything we get as our M is not going to be 16. Then it can never be 16. So for us to calculate our M, what we're going to do is that we're going to say, first of all, we have elements. So we're going to say, first off, we have 90 over this abundance over 100. Are we there now? Now we'll come here, we look at this particular element. Remember, what we're going to multiply this is with the mass number. So 90, which element has 90 over 100? Is this element with mass number. So we're going to do the mass number. Now plus, we get the other abundance, relative abundance of 10%, 10 over 100. Are we there now? Now times, they didn't give us the mass, so we say the molar mass is what? M. Are we there now? Everything here is equal to what? Is equal to 16.2, which is the relative atomic mass, 16.2. So I'm going to say 9 into here. I'm going to have 9 over 10 times 16 plus this into here. I have 1 over 10 times M. So this is the same thing as 16 times 9. 16 times 9 is equal to 144. This is the same thing as 144 over 10 plus M over 10 equals 16.2. Are we there now? Equals what? 16.2. Now, in this scenario now, what we're going to do is that we're going to try as much as possible to collect like terms. Are we there now? If we collect like terms, what I'm going to do that, what is the LCM of this and this? Is 10. 10 into here, 1. 1 times this, 144. Plus 10 into this, 1. 1 times this is M. So this is the same thing as 144 plus M over 10 is equal to 16.2. I will cross multiply. So I will have 144 plus M is equal to 16 times 10. 16.2 times 10 is equal to 162. So I will, divide by, I'll collect like terms, CLT. Collecting like terms simply means M will be equal to 162 minus 144. I will do now. So I will say 162 minus 144. My M is equal to what? Is equal to 18. So if I come here, the value of my M here is 18. So my answer is what? Number B. Did you understand what we did here? Good. Now question 37. It says, the liquescent substance are used for. When we're talking about the liquescent substance, the liquescent substance are substance, that absorb water when we expose them to the atmosphere. We have what we call efflorescence, we have hygroscopic, and we have the liquescent. The liquescent and hygroscopic are synonymous. Where one, when absorbs water, forms solution. The other, when absorbs water, forms what? A moist or sticky substance. So when we're talking about the liquescent substances, since they absorb water when exposed to the atmosphere, that means they can be used to dry substance. Are we there now? Because when we're talking about drying, you absorb water, you remove the water. So the liquescent substance can also be used as what? As drying, not cooling, not wetting, not what? Melting. Question 36. It says 4 elements W, X, Y, and Z have atomic numbers of 2, 6, 16, and 20 respectively. You say, which of these elements is a metal? Which of these elements is a metal? The simplest definition of metal is that metals are electropositive elements. What do we mean that they're electropositive elements? They have the ability to give out electron, easily give out electron. They easily do it. So if we come here, let's look at element X. First, W is 2. Are we there? W is 2. X is 6. X is 6. Y is 16. Y is 16. And Z is what? Z is 20. Are we there now? Now, when we say element 6, let's say X is 6. What we mean is that X being 6, according to principal electronic configuration, is going to be 2 and 4. W being 2, W simply means it's just 2. And Z 20, we are going to have 2, 8, 8, 2. And then if we come to Y 16, we are going to have 2, 8, 6. Now, this particular man here, between this X 2 and 4, it cannot give out the 4 electron because this is the electron in the outermost shell. X cannot easily give out these 4 electrons, so it's not a metal. Are we there now? Because in the outer shell there are 4 electrons. Are we there now? So this X is not a metal. If we come to W has a complete field duplex structure. Are we there now? So it's not what? It's not a metal too. It doesn't have what? It doesn't have any electron to give off. The duplex structure is complete. Something like this and this is complete. It can't give out 2, it can't accept. It's just complete. So this is not a metal. If we come to Y is 2, 8, 6. The first structure is complete, second structure is complete, but this particular one, there are 6 electrons. So it needs 2 more electrons to complete its octet structure. So because it needs 2, we are going to say that this Y is Y2 minus. So this one is a non-metal, not a metal. Meanwhile, if we come to Z is 22, 8, 8, 2. The first structure, the shell is complete, second shell is complete, third shell is complete. But in the fourth one, there are 2 free electrons outside. So this man can easily give out these 2 electrons. That's why we can see that the valence here is what? 2 plus. So Z is what? Is a metal. So my answer is what? Is Z. Are we there now? Now, if I come to question 35, it says sucrose is made up of dash. Sucrose is a disaccharide. Are we there now? For a disaccharide to be formed, there must be 2 combinations of what? Of monosaccharide. There are 3 important disaccharides that you must know. We have lactose, we have sucrose, and we have maltose. Now, glucose plus glucose will form what? Will form maltose. Glucose plus glucose will form what? Maltose. Glucose plus fructose will form what? Sucrose. Are we there now? Now, glucose plus galactose will form what? Lactose. These are the 3 important disaccharides you must know. Are we together? So, sucrose is made up of what? Glucose and fructose. So, our answer is what? Our answer is B. To question 34, it says alkanones. Alkanones are the same thing as ketones. Alkanones are generally obtained by the oxidation of dash. A. Primary alkanones, B. Secondary alkanones, C. Tertiary alkanones, D. Alkanoic acid. Now, what is the general formula for alkanones? Alkanones is RCO R prime. Are we there now? That means CO is in between. Are we together now? Now, if we come to primary alkanones, what are primary alkanones? Primary alkanones have the OH functional group attached to the primary carbon atom. What is a primary carbon atom? A primary carbon atom is that carbon atom that is only attached to one other carbon atom and every other substituent. Say for instance, if I have something like this, C, and then I have OH. I have H. This is a primary alcohol. Why is it a primary alcohol? Because the OH is attached to this primary carbon atom. Why is this a primary carbon atom? It's a primary carbon atom because it's only attached to one carbon atom and substituent. Are we there now? Now we have secondary alcohols. This is an example of a primary alcohol. When the OH is attached to what? Primary carbon atom. This is a primary carbon atom. This is a primary carbon atom. Are we there now? So when we're talking about secondary alcohol, something like this. Are we there now? And then I have substituent. This is an example of a secondary alcohol. Why is it a secondary alcohol? Because the OH group is attached to a secondary carbon atom. What makes it a secondary carbon atom? It's a secondary carbon atom because it has two other carbon atoms surrounding it. It has what? Two other carbon atoms. Only two. Primary is only one. Secondary only two. Now when we're talking about tertiary alcohol. Tertiary alcohol have the OH group. Are we there now? OH group attached to what? Attached to three other carbon atoms. Are we together now? That's example of what? Of a tertiary, carbon atom. So in this scenario now, this is a tertiary alcohol. Why is it a tertiary alcohol? It's a tertiary alcohol because the OH is attached to a particular carbon atom that has three carbon atoms surrounding it. Did you understand? So if we come here, we say ketone is RCOR prime. That means it starts with R, CO comes in between, and then R prime. So where can we form, our ketone from? Where can we get our alkanones? Where can we obtain them? Is it from primary alcohol? Is it from here? Of course we can't, because ketone, OH, the O is usually in between. Are we there now? So where can we obtain them? We can obtain ketone from secondary alcohols. Why? Let's take, for instance, I have something like this, C, and then I have C. And then I come here, I have OH. This is H, 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 this is H. This is propan 2O, this is propan 2O, prop 2O. Are we there now? OH surrounding the what? The secondary carbon atom. So from here I can get my alkanones. If I oxidize this particular stuff, what is oxidation? Oxidation is removal of hydrogen. Are we there? And then addition of oxygen. So let's remove this particular hydrogen here. I'm going to have something like this, C, H, and then I'll have C double bond O. These two hydrogen will be out, and then I'll have C, H. I've formed a ketone. What's the name of this ketone now? This is propan or prop2-on. Are we there now? From prop2-or to what? Prop2-on. So this is a ketone or alkanone. So alkanones can be formed from what? Secondary alkanones, not primary, not tertiary, not what? Alkanoic acids. Now question 33. The reaction of carbide with water gives, let's look at the reaction of carbide. Carbide is usually CaC2 now plus H2O. I will take this C2, take it here. I'm going to have C2H2, which is the main thing that will be formed, and then plus CaO. Are we there now? Plus what? CaO. This is the main thing that is going to be formed. In this scenario now, what have I formed? I formed C2H2. What is the name of this C2H2? C2H2 is what? It's ethyne. Are we there now? C2H2 is what? It's ethyne. So my answer here is what? It's ethyne, not ethane. Ethane is C2H6. Ethene is C2H4. Ethanol, what is ethanol? Ethanol is CH3CHO. Question 32. It says, the refreshing and characteristic taste of soda water and other soft drinks is a result of presence in them of dash a carbon 4 oxide, which is entered as carbon dioxide, carbon 2 oxide, which is entered as carbon monoxide, soda or glucose. So they're asking the refreshing and characteristic taste of soda drink and other soft drink, like the sweet taste and everything. What brings about it? Now we'll come here, we'll look at, the answer is not glucose. Are we there now? But rather the answer is what? Carbon 4 oxide. Are we there now? So carbon 4 oxide is what brings about the refreshing and characteristic taste of what? Of all soft drinks. You know examples of soft drinks, your Mirinda, your Pepsi, all those soft drinks, they are all examples of what? Of soda or soft drinks. So the answer is what? Carbon 4 oxide. Now if we come to question 31, it says a phenomenon where an element exists in different forms in the same state. This is an important question. Please don't forget this. Now the answer is not isomerism. Are we there now? The answer is not isomerism, because in isomerism we are saying that they have same molecular formula but different spatial or structural arrangement. Now the answer is not amorphism. The answer is not isotopy. In isotopy, what are we focusing on? In isotopy, we are saying they have same atomic number but different what? Mass number. So the answer is what? Allotropes. Are we there now? The answer is what? Allotropy. That's why in carbon, there are different allotropes of carbon. We have diamond, we have graphite. All of them, are we there now, exist in the same physical state, but just that they are what? In different forms, but in the same what? Physical state. Let's look at question 30. It says 0.46 grams of ethanol when burned raised the temperature of 50 grams of water by 14.3 Kelvin. Calculate the heat of combustion of ethanol. Now they give us in bracket carbon equals 12, O is equals oxygen, H equals 1. They're talking about molar masses. And then they say specific heat capacity. HSC simply means specific heat capacity of water equals 4.2 joule per gram per Kelvin. Remember, you have to solve with what was given. In most cases, they usually give 4,200. So, but whenever they give you 4.2, please try as much as possible to use it and solve. Now, when we're talking about heat of combustion is usually an exothermic reaction. Heat is given off in the surroundings. So, the result is usually negative. Are we there now? Since we're talking about heat of combustion. So, for us to calculate, the heat of combustion, I would say heat of combustion is equal to negative value. Anything I get must be negative. I would a negative value of heat absorbed by water, heat absorbed by H2O. I would now all over number of moles of ethanol. Number of moles of ethanol. I would now. So let's calculate first of all heat absorbed by water. So let's use change in H as heat absorbed by water. Change in H of water. Change in H of water. Are we there now? We use MC theta. We use what? MC theta. Remember, we're talking about H2O, water. So we look at 3.46 grams. This is mass of ethanol. This is mass of water. So we are going to use mass of water. We'll now say equals, anywhere we see M, we put 50 grams, 50 times. Anywhere we see C, which is specific heat capacity, we put 4.2. And then whenever we see temperature is 14.3. So we say times 14.3. So our change in H will be equal to, say, 50 times 4.2, 50 times 4.2 times 14.3. So I have 3003. So I have 3003 joules. I would 3003 joules. So let's calculate the number of moles of ethanol. So we say number of moles of ethanol, ETH, will be equal to, remember, according to our stoichiometry, mass all over molar mass. So I'm going to say mass all over what? All over molar mass. Are we there now? First of all, we already have the mass of ethanol as 0.46 grams. But what is the molar mass? Molar mass of ethanol. What is ethanol? C2H5OH. So let's calculate. It's equal to C. What is C here? 12. So that means 12 times 2. 12 times 2 plus hydrogen is 1. So 1 times 5 plus oxygen is 16. 16 plus hydrogen is 1. Are we there now? So we say 12 times 2, we have 24 plus 5 plus 16 plus 1, 17 plus 17. So when we calculate together, we have 24 plus 5 plus 17. 24 plus 5 plus 17. We have 46. Are we there now? Am I right? 24 plus 5 plus 17, 46. So we have 46 grams per mole. Equals 46 grams per mole. So I'm going to say number of moles here. N ethanol will be equal to, what is my mass? Mass is 0.46. What is my molar mass? 46 grams. So I'm going to have 0.46 over 46. I have 0.01 moles. 0.01 moles. Are we there now? So I will say heat of combustion, which is, let me use, heat of combustion. Let me use change in heat of combustion is equal to, remember, negative value of, what is my heat absorbed by water? Heat absorbed by water is minus 3003 joules. sorry, 3003 joules, not minus. So 3003 joules all over. What is my number of moles of ethanol? 0.01. So I will have 3003 over 0.01. What do I have? I have 300 joules. Since it's heat of combustion is negative value, are we there now? Is negative what? Negative value. So we say, so we now say, we come here, we say, so I will now come here, I will convert to kilojoules because all my answers here were in kilojoules. So I'll convert to kilojoules, divide by 1000. I'll move here 1, 2, 3. So this is the same thing as minus 300 kilojoules. Are we there now? That's my change in heat of combustion. Are we there now? You know why it's negative? Negative because it's what? An exothermic reaction. In exothermic reaction, heat is usually what? Given off. Are we there now? So this is what? Minus 300 kilojoules. Where do we have minus 300? Number C. Are we there now? So my answer is what? Is C. Now let's look at 29. It says MnO4 charge plus 8H plus, plus Y will give me Mn plus 4H2O. Now, if you look at this particular place, they ask us why in the equation represents what? Now, what they're talking about is balancing of the charges that are present. Now, I want you to understand something. If you look here, the total charge at the right-hand side is 2 plus. Are we there now? The total charge at the left-hand side is 8 plus minus 1, 7 plus. Are we there now? So I want to make this particular charge. Let me come again. I said the total charge here is 2 plus. If you can see, this is 2 plus. The total charge here is 8. 8 times hydrogen is 8 plus. So we have 8 plus minus 1. Minus 1 plus 8 is plus 7. So the total charge at the left-hand side is plus 7. Are we there now? And the total charge at the right-hand side is what? Plus 2. Are you getting what I'm saying? So I want to make sure that the left-hand side is plus 2. Are we there? I want to make sure that here is plus 2. So what will I add here to make sure that here is plus 2? If I add 4 electron, here will be plus 3. If I add 5 electron, I will have 7 plus 5 electron to give me 2 plus. So 7 plus and 5 electron, I have 2 plus. Are we there now? And then I have what? 2 plus. So for me to balance here, my Y will be what? 5 electrons. Are we there now? So I come here, my answer is what? Is C. Okay, to question 28. It says, the pOH of a solution of 0.25 mole per dm cube of HCl is dash. They're asking us to solve for pOH. Now, first of all, I want you to understand something. We say that pOH is equal to negative logarithm of hydroxy ion. And then we have pH is equal to negative logarithm of what? Hydrogen ion. Now, for us to calculate the pOH, that means they would have given us the concentration of hydroxy ion. But in this question, what they gave us was, an acid content. So that means we are going to solve for what? pH first. So what is the relationship between pH and pOH? Now, the relationship between pH and pOH is when we say pH plus pOH is equal to what? Is equal to 14. Are we there now? So this is the relationship. First of all, let's solve for our pH. If we solve for pH and then we get pH, we make pOH the subject of the formula to get our answer. Now remember that your value, when you add both of them together, must not be greater than 14. Are we there now? I'm seeing our option where we're having 14.40, 14.60. These two are already wrong. Are we there now? Because you cannot have pH plus pOH greater than 14. It can never be greater than 14. It must be less than or equal to what? 14. So these two are already wrong. So, but let's solve for pH. So I will say pH will be equal to negative logarithm. What is my hydrogen ion here? My hydrogen ion is what? 0.25. So I will say pH will be equal to negative. What is log 0.25? I have minus bracket 0 minus 0.6021. Are we there now? So minus times minus is plus. So pH is equal to 0.6021. Now, to calculate my POH, I will say I will come here, I will make POH sort of formula. I will say POH will be equal to 14 minus pH. From this particular formula, this man crosses the equality sign to turn to negative. So my POH, which is what they asked me to find, will be 14 minus, what is my pH now? 0.6021, which is equal to 14 minus 0.6021. I have 13.3979. 13.3979. How many decimal places? We have 2 decimal places here. So this is the same thing as 13.40. So we'll come here. The answer is what? Number B. Are you getting what we are doing here? Good. Now, question 27. It says the distance between the nuclei of chlorine atoms in a molecule is 0.194 millimeter. The atomic radius is dash. Now, when we're talking about nuclei, a nuclei, we're talking about two different atoms of molecule. Say, for instance, this is chlorine. Chlorine is what? 1717. So if this is 2 and then we have 8, look up. This is 8, this is 7. Now, this is chlorine atom. This is another chlorine atom. Another chlorine atom. Now, we'll come here. Oh, there now. We'll come here. This is 8. Please look up. Focus. And then we have another 7. Oh, there now. These are different chlorine. This is chlorine and chlorine. When they come together, we call them chlorine molecule. That's when we have something like this, Cl2. If you look at the question, it says the distance between the nuclei. Nuclei simply means, the distance between these two atoms. So the distance from here, between here and here, we say that the distance is what? 0.194 millimeter. So they're asking us the atomic radius. They are no longer asking the nuclei of this molecule. They're asking what is the atomic radius of this particular what? Of a singular chlorine atom. So that means for us to get, since the distance between this and this is 0.194, we need to get the atomic radius of only this particular chlorine atom. That's when we come 0.194 over 2. Are we there now? 0.194 over 2. So we have 0.194 over 2. So 0.194 over 2, we have 0. Which is equal to 0.097 millimeter. So we'll come here. The answer is with option A. It says, to question 26, it says, the electronic configuration of X atomic number 22, valency of 2 plus ion is dash. Now, look at the options they give us. 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 4s2, 3d2, up until, we got to the D part. Now, I want you to understand something. When we're talking about an element like this, and then we're talking about charge, remember, this means that this is an element. So for us to have a charge, and then they're asking us about the electronic configuration, what it simply means is that we're not going to look for the atomic number 22 in configuration. Are we together? Remember, in configuration, we have principal configuration and azimuthal configuration. In this scenario, this is azimuthal configuration. So what happened here is that 2 plus ion has been given off. So if 2 plus ion has been given off, are we there now? In an element with the atomic number 22, the electron remaining here will be what? Will be 20. Are we there now? The electron remaining will be what? Will be 20. So if it has given out 2, because it's a metal, it can easily give out 2 electrons. That's why it's 2 plus. Are we there? So if it gives out this particular 2, the remaining, electron here is what? Is 20. And we can use 20 to solve for configuration. If we come here, we'll count the configuration. We have 2, 6, 10, 12, 18, 20, 22. So this is not the answer. If we come here, this is 2, 2, 6. That's 10, 12, 18, 20, 21. This is not the answer. If we come here, 2, 2, 6, 10, 12, 6, 18. This is not the answer. If we come here, 2, 2, 6, 10, 12, 18, 20. This is the answer. I would not, because the remaining electron here is what? Is 20, and we are going to use 20, to actually configure that particular element. When it's positive, it can give out. And if you have something like X22, are we there now? And then we have something like 3 plus. the remaining electron here is 19. Are we trying? Because it has given off 3. Or had it been, we have something like this, x22, 2 minus. What it means is that this particular man has accepted 2 more electrons. So the remaining electron here will be what? 24. And we are going to use 24 to configure. I hope that makes sense. Alright, so let's continue. Question 25. It says, the fundamental difference between the 3 states of matter is the dash. Now, there are 3 states of matter, solid, liquid, and what? And gas. So what is the basic difference? Are we there now? What is the most important difference of these 3 states of matter? 1, is it at the shape of the particles? No. The fundamental difference is not the shape of the particles. Are we there now? It's not like the shape of the particles are the same, but that's not the basic difference. The number of particles in each state? No, that is not the fundamental difference. The shape of the container they occupy? That is not really the main difference, unless we're only talking about liquid, because liquid takes the shape of the container they do what? They occupy. Now, if we come to see the D, degree of movement of the particles, yes, that is the answer. Because these 3 states of matter, the fundamental difference between the 3 of them is that their degree of movement differs. Are you getting what we are saying? Remember, in solid are compactable, they are jam-packed together. Are we there now? Solid are what? Are jam-packed together, like there is no space. Are we there now? Their movements are restricted. If you come to liquid are kinda, they give space from each other. Are we there now? They are not completely jam-packed as that of solid. This is solid, this is liquid. And then if you come to gas, this is the movement of gas. Gas are, they move freely. That is why when you want to put gas in a particular container, you have to compress it because their movements are free. They move freely. Immediately you open a container containing gas, the gas will just move out immediately. As opposed to solid and what? And liquid. To question 24, it says the partial pressure of oxygen in a sample of air is 452 millimeter mercury and the total pressure is 780 millimeter mercury. What is the mole fraction of oxygen? Just so you know, when we're talking about mole fraction, we use the formula mole fraction is equal to, we say, partial pressure all over total pressure. How would you now? Partial pressure all over what? All over total pressure. Now, what is my partial pressure here? My partial pressure is 452. What is my total pressure? 780 millimeter mercury. 780 millimeter mercury. So my mole fraction is 482 over 780. I'm having 452 rather. 452 over 780. I mean 0.579. 0.57949. Here, what do I have? 3 decimal places. So my mole fraction is equal to 0.579. Where is the answer here? My answer is B. Now, if we come to question 23, question 23 says the ratio of the initial to the final pressure of a given mass of gas is 1:1.5. Calculate the final volume of the gas if the initial volume was 300 cm3 at the same temperature. So this is Boyle's law, pressure and volume. I remember in Boyle's law, we say that P1 V1 is equal to what? P2 V2. What are they asking us to find? Calculate the final volume. So for us to calculate the final volume, we divide by the coefficient of V2, which is what? Which is P2. So here P2, here P2. So cancel. So V2 is equal to what? P1 V1 all over what? All over P2. Now, first of all, they say the ratio of the initial to the final pressure. That means the ratio of the initial to the final is 1:1.5. I can use my P1 as 1 and P2 as 1.5. Or I can look for numbers that when I divide them, this one, there will be a difference between the final and the initial to be 1.5. So I can either say my P1 to be 1, my P2 to be 1.5, or I will say, let me use 3/2. Or I will say my P1 will be 2, my P2 will be 3. So that when I do 3 over 2, I will still get 1.5. I don't know if you are getting what I'm saying. So in this scenario now, I can say, if you want, you can use P1 as 1 and use P2 as 1.5. You will get the same as I'm going to get. Someone else should use P1 as 2. Another person should use P2 as 3. You still get the same answer. Another person should use P1 as 4. The other person should use P2 as 6. You still get the same answer. Because when you do them, you get 1.5 in their difference. So that's 1:1.5. So in this scenario now, let me say P1 is 2. Let me use P1 equals 2 and P2 equals 3. Because so that when I do 3 over 2, I will get 1.5, which is this. Are we together now? So, and then already my V1, what is my V1 here? 300 cm cube. 300 cm cube. So I will impute, I will now say P2, V2 rather, will be equal to, anywhere I see P1, I'll put 2 times. Anywhere I see V1, 300. Anywhere I see P2, I'll put 3. So 2 times 300 is what? 600 all over 3, which is the same thing as 600 over 3. What do we have? We have what? 200 cm cube. So I'll come here. My answer is what? My answer is B. Okay, to question 22. It says 50 cm cube of carbon 2 oxide was exploded with 150 cm cube of air containing 20% of oxygen by volume. Which of the reactants was in excess? A. Carbon 2 oxide. B. Carbon 4 oxide. C. Oxygen. D. Nitrogen. Now let's first of all understand what we are saying. Now they said carbon 2 oxide, it was exploded with oxygen. So that means CO plus oxygen gas. Of course, we are going to have CO2. Are we there now? Now we have O2 here. We need to balance. Are we there now? So if I add 2 CO here, I need to add 2 here. So that I have 2 carbon, 4 oxygen, 2 oxygen plus 2, 4 oxygen. Good, is balanced. Now before the explosion, we say 50 cm cube of carbon 2 oxide. So that means 50 cm cube of carbon 2 oxide before the explosion. So if 50 cm cube was available here, well, how many cm cube will be here? Because here is 2 moles, here will be 1 mole. So if here is 10, here will be half of 10, which is 5. Are we there now? So here, because it's 1, I'm going to say here will be 25. Are we there now? 25 cm cube. Because we're talking about reactant, let's leave product. They're asking us of what? Of reactant. The 2 reactants here are carbon monoxide and what? Oxygen gas. So that means carbon 4 oxide is not an option. Nitrogen is not an option. Are we there now? Because these are the 2 reactants. Now, this is what is needed for the reaction. But during explosion, another volume was introduced. We say 150 cm cube of air containing 20% of oxygen. So that means we are going to do 150 times 20 over 100. Are we there now? So what will happen is 0 cancel 0 here, 0 cancel 0 here. So what happened here is that we have 30 cm cube of oxygen was now available after explosion. Are we there now? So they're asking us now, which of the reactant was in excess? Now, if we begin to see, that this is 30 cm cube. Are we there now? This oxygen. Meanwhile, what is needed in the reaction was just what 25 cm cube. So because we have 30 cm cube, we can say that 30 is greater than 25. Are we there now? So we say that oxygen is the one that is in what? In excess. Because the only thing that is required for this reaction to happen is just 25 cm cube of oxygen. But after explosion, we are seeing 30 cm cube. That means oxygen was too much. So the answer is what? Is oxygen. Are we together now? Good. Now, to the next question, we say ethanoic acid is. What is ethanoic acid? Ethanoic acid is something like CH3COOH. So ethanoic acid is a tribasic, unionizable, monobasic, or dibasic. Now, in this particular topic, this is a topic called basicity of an acid. That's the topic I taught my student. Now, I told them that basicity of an acid is the number of replaceable hydrogen ion. Are we there now? That is present in what? In a specific acid. What is the number of ionizable hydrogen ion that can be replaced by a particular metal? Are we there now? That number of hydrogen is called what? Basicity of an acid. If we come here, basicity of an acid is not the number of hydrogen. It's only the number of replaceable hydrogen ion. If we come here, how many number of replaceable hydrogen ion do we have here? It's just this particular H. That is why you can have something like this, CH3COONA. Are we there now? So that means this hydrogen has been replaced by this what? By this metal. So the number of replaceable hydrogen ion here is just 1. And when it's only 1 replaceable hydrogen ion, The name of that basicity is what? Monobasic. Is what? Monobasic. Are we there now? So our answer here is what? Is monobasic. Now we also have another basicity called dibasic. Dibasic is something like H2SO4. Are we there now? The number of replaceable hydrogen ion here is what? 2. That's why we say we can have something like Na2SO4. Are we there now? So this is what? Dibasic. We also have tribasic. Tribasic is when we have 3 number of replaceable hydrogen ion, like H3PO4. So when these 3 hydrogen ion are replaced, basicity of an acid is not the number of hydrogen, but the number of replaceable hydrogen ion. Thank you for watching.